All right, so welcome everyone. Thanks for joining us today. We have a really awesome presentation for you. Benjamin Harvey is from the Databricks University Alliance program, and he, along with Rob Reed, who's the program manager, are going to talk a little bit about the program and how they got into data science. And also Ben is going to be talking about unifying data science and business, so artificial intelligence augmentation and integration into production business applications. So this is part of the Data and AI online meetup group. So if you're joining us from LinkedIn or YouTube, I'll drop the link to join that group there. If we would love for you to join, we post all of our upcoming tech talks. They're all live and they're all recorded. And they live on our YouTube channel. So we have a meetups and tech talks playlist there. So I'll drop the link there as well. So we have lots of awesome sessions. Everything that we've done as part of this meetup group lives there, as well as all the content you could ever imagine. We have a lot of sessions from our past conferences and a lot of other awesome playlists. So I invite you to check that out. So I wanted to quickly give a shout out to the Databricks community. So hopefully some of you have already checked this out. Maybe you're new, but we recently launched in the last, I think about 2 months or so now, the Databricks community. So this is where you can get all of your answers or all of your questions answered. Chime in, join others, have discussions. And this isn't just about Databricks. So it's also about, kind of related open source projects. So including Apache Spark and Delta Lake and MLflow. So I invite you to chime in there. Again, ask questions, answer other folks, and hopefully see you online. And then really awesome to hear, Data Brew is a podcast series that we run. So it's ran by Denny Lee and Brooke Wenig, and they're in their 3rd season, which is super amazing. And these podcasts are available wherever you like to listen to them. So this season is all about how leaders use data for change. So we have a previous season, so 2 more that are still available that you can check out all that content. So I'll drop that link too when I'm done with my intro slides, so you can check out podcasts. And then really exciting coming up is the Data and AI World Tour. So we're putting together a global live cast series, and you can kind of see here some of the dates for each of the sessions. And then also too, we're going to be running a few live meetups in coordination with those live cast events. So I invite you to check out the pages. Again, I'll send the link so you can check out the content. But really, this is all going to be about Lakehouse. So learn how Lakehouse simplifies your data architecture by unifying all your data, analytics, and AI in one platform, and dive deep into the latest innovations on the Databricks Lakehouse platform through practical use cases and real customer scenarios. And again, we'll have some cool tech talks, meetups planned at the end of a couple of those sessions. So I invite you to check that out. All right, I'm done with my announcements. Before I pass it over to Ben and Rob, I just wanted to remind everyone that this session is recorded. So I'll drop that link to the YouTube recording in there. We invite you to ask your questions. Rob and I will be moderating the chat spaces on Zoom and LinkedIn and YouTube. So ask away, ask your questions there. We'll have some time at the end for Q&A. And I think that's it. So without further ado, I'll pass it over to Rob.
So I don't have a whole lot to say, except it's an extreme honor and privilege to introduce Dr. Ben Harvey and the work that he is doing. I can see that a fair number of the participants and attendees are members of the Databricks University Alliance. Basically, we at Databricks are trying to help you teach your students analytics using the Databricks platform. For all the obvious reasons, but I think it's a great way. I love my job because I get to help people teach students more effectively using the Databricks platform. So for me, this is a service job, and anything I can do to help out, I'm absolutely delighted. So with that, I'll turn it over to the man with the most important content, Ben, and I'll join Karen monitoring the Q&A.
All right. Thank you so very much, Rob. All right, so let me go ahead and share my screen. Right. Okay. Karen, are you good? Can you see that?
Yeah.
Thumbs up?
Yep.
All right,
Yeah.
excellent.
Looks good.
All right, perfect. All right, so, following on that theme of the University Alliance, today I'm going to talk a little bit about, cultivating the next generation of data scientists. I'm going to talk a little bit about the experiences that I've had within the University Alliance program, specifically three of the courses that I've taught using Databricks, utilizing Apache Spark, pushing best practices associated with, building out platforms and allowing these students to, run their data science algorithms, as well as methodologies within the Databricks platform, allowing them to have the workspace environment that allows them to collaborate and engage in ways in which is very useful for the classroom setting. So I'll talk a little bit about, the value that the University Alliance program has had in cultivating and creating and in help engineering that next generation of data science. And then I'll pull on a particular thread that deals with, artificial intelligence, augmentation, and integration. We're going to talk about, the next generation data scientists and how they're going to be using some of the methodologies to help, not only just from a deployment perspective, but also how do you take the machine learning models, the results, and then integrate those into the workflow of the end user, which is a misnomer for the data science community in regards to how to seamlessly be able to integrate those results and to seamlessly create the intersection between the machine learning results and the application. All right, so for the agenda today, I'm going to talk about a little bit of my background, introduce the topic, and then we're going to jump into, what does it mean to cultivate that next generation of data science talent? And then we're going to talk about, this kind of, new ideal that, this new way of teaching data science using this, collaborative workspace environment that allows the students to, engage and run machine learning algorithms at scale across, in my, computational bioinformatics class, large scale cancer genomics data sets, right? And then I'll talk a little bit about, the theme of artificial intelligence, augmentation, and integration. How can you augment, the analysts? I'll talk a little bit about my background at the National Security Agency and working with, 30,000 analysts and being able to develop capabilities that can help augment the analysts to point them to the most significant insights within their workflows. And then we'll jump into, more on the topic of, how do we accelerate and integrate the machine learning and artificial intelligence into those business applications? We'll talk about the problem, the opportunity, solution, and then we'll talk about a little bit of, some of the technology I've been working on and how that's been able to integrate with the Databricks platform. All right, so jumping right into it. So again, guys, my name is Benjamin Harvey. I did my PhD at a school in Bowie, Maryland called Bowie State University. I left from the area and I went to Harvard and MIT, as well as Harvard Medical School and Brigham's and Women's Hospital for those who are familiar with the Boston area. I did about a year and a half research at BWH, working specifically with large scale cancer genomics data sets and applying machine learning algorithms to that data. I came back to the Maryland DMV, DC area, and I worked at the National Security Agency for about 10 years, where my last position there was the Chief of Operations Data Science. So I was the lead data scientist for the operations directorate. I had a team of about 40 senior data scientists, and we worked on some of the most challenging problems from across the agency. Not only did we work on, how do we answer some of the requirements associated with analysts that needed to understand their data sets, but also helping the national security understand how do we scale data science and machine learning algorithms across the large scale distributed repositories within the organization. I ended up leaving there. I am a previous Brickster. I worked at Databricks for about a year and a half as a data scientist and solutions architect. I did leave there and I went to a company called Maxar. I was their director of data science. And most recently, I headed back to academia where I met Rob in my current position as the senior research faculty at Johns Hopkins University, as well as research professorship. I'm appointed professor at George Washington University, as well as Bowie State University. And last but not least, I just started a company, and I'm the CEO and founder of a company called AI Square. We'll talk a little bit about the tech that I've been working on that deals with augmentation and integration. All right, so let's start off with, I've been in the data science community, for a while, ever since, really I started at George Washington University as a research professor back in around 2016 or 2017. And what I've seen is, we talk about this data science Venn diagram where you have your computer science, you have your mathematics, and you have your subject matter expertise. And in these different areas, we've seen a lot of innovation, innovation around, automation in that computer science area of the Venn diagram. And then for the statistical processing and the statistics, we've seen a lot of, how do we increase the validity and the validation of the data that's coming through some of these algorithms. And then going into the actual subject matter expertise area, you start to see more and more academic institutions and organizations trying to identify ways to increase the intuition that's associated with decision making. Okay. Now, what we started to see is that in each one of these different areas, across, you think about machine learning, the traditional research, and the traditional software development, there's areas of risk. Okay. And you think about machine learning, you think about the drift and the bias, all the way through to the traditional software. You think about how some of that is unproven. The idea is that now a lot of organizations are putting resources into identifying methods to help reduce some of the risk. And this is where the opportunity has come forth in a lot of academic institutions for data science practitioners that are also teachers of data science to be able to start teaching in different areas that are associated with these risk categories, right? So, an area that I teach is artificial intelligence assurance, right? So, thinking about adversarial machine learning, thinking about, the adversarial attacks that can happen either on the data or the model, how do you secure those, right? And then thinking about, explainable AI and ensuring that the machine learning models are able to be interpretable by not only the data scientists, but by end users that might want to consume the results of those algorithms. And then, you think about the quality of the data itself, right? So garbage in, garbage out. Organizations, institutions are really focusing in on how do we teach our students to increase the quality of the data so that they can start to get an increased accuracy and performance of their models as they are pushing the data through the algorithms. And then the performance, right? So you start to think about some of the automation tasks associated with the computer science and the hyperparameter tuning and things like that. But as the models start to get more and more complex, there's a lot of areas of research that deals with, how do we increase the accuracy and the performance of the models while decreasing the size and the complexity of the actual algorithms, right? So things like pruning and sparsification of the network to be able to decrease the size for things like edge deployment, but also to reduce the complexity to increase the speed at which the inference can actually happen. Okay, so these are all opportunity areas. And what we're seeing is that as the data increases, there's more complexity associated with being able to start to conduct exercises and experimentation in these different areas. So this is another way that the Databricks platform in regards to the students and being able to teach the students has been very, very, very valuable for us, because as we start to think about, all right, we want to have the students working with large data sets so that we can start the test to see if a large representation of data being trained against a model, is it still a representation of what we'll actually be seeing in a live production application or a live production data coming through the model. So, what does the next generation of data science talent look like? It's trying to identify some of these areas of risk and then applying some of the innovation and next generation technologies to these different risk areas. And Databricks has provided an excellent opportunity for us to be able to do that. So, thinking about some of the transformational topic areas that are associated with some of these risk categories. So the first one we talked about was artificial intelligence assurance, ensuring that the models as well as the data are created in a way that can reduce the adversarial activity that might be associated with either one of those different models or the data sets themselves. And then looking at things like bias and trust in machine learning. So there's this new area of trustworthy AI, right, where organizations are putting a lot of time, energy, and resources into making sure that the data is not the models aren't biased, the data coming in isn't biased, it's a full representation of the population of data. But also from a how do you ensure that the end user analyst that is responsible for interpreting and in many cases reporting or looking at the KPIs for reporting or generating reports from the results of the machine learning models, how do you ensure that they're going to actually trust the results that are coming from the machine learning algorithms? And then the topic of explainable AI or XAI, thinking about making sure that the models are interpretable in a way in which that trust mechanism can also be fostered to have that trust in regards to not only can the analyst or the end user understand the results, but they can also understand the methodology for how the results were actually created. And then looking into artificial intelligence, augmentation, and integration. We're going to talk a lot about this today. And the idea here is, how do you augment the cognitive decision-making process of the analyst to point them to the most significant insights within their workflows, right? So this goes one step beyond deployment to say, hey, we want to make sure that you don't have to learn a new application, and you can receive the results of a machine learning algorithm directly in that workflow, okay? Directly in the 4 or 5 tools that you use on a day-to-day basis. And then there's the notion of data-centric AI. So how do you increase the quality? How do you engineer new data and then increase the accuracy of your models and the performance of your models by just using the data and not necessarily hyperparameter tuning to increase the accuracy? And then machine learning at the edge, which is directly coincides with the model optimization, which is things like pruning and doing things like sparsification and distillation of the machine learning networks to reduce the size and to compress the models so that you can deploy them to the edge, whether it's the browser or whether it's an IoT device where you're trying to get the model as performant as possible to be able to run on constrained resources. And then, a lot of this boils down in organizations in academia as well as industry are looking at how do you mimic or have your AI mimic that intrinsic human behavior, right? Where, humans are naturally able to do multiple tasks, right? They inherently can do natural language processing, computer vision, and regression at the same time, right? So how do you create these multitask models? And then how do you create models that are doing things like focus, right? Where you have one task that it has more focus than a separate task, where you're doing natural language processing, but when a computer vision task comes in that's of high importance, you can switch tasks and put more focus on that task and put more of the machine learning neural networks on that particular task to increase the accuracy on that task and perform less accurate on a separate task. So things like focus. So that intrinsic human behavior. And then the last thing is like the human machine teaming and the, having the human in the loop. So a lot of organizations, think about healthcare, think about the Department of Defense and the intelligence community. A decision can be detrimental and it can affect someone's life. So there's a lot of onus on having the human in the loop, so that even when a machine learning model makes a decision, that there's a human that can validate and vet that decision before it can have catastrophic second order effects. Right. So let's talk a little bit about, the new way of teaching data science using Databricks. So this is going to be my fourth class, the fourth class teaching using Databricks. Okay. And I'll talk a little bit about why it's been so valuable and why the students and why the faculty, as well as the within the institutions, have started to also leverage and see the value of using a Databricks environment for teaching. So the first course is the first ever was this fall of 2021 at Johns Hopkins University, which is the #1 school of public health in the country, and I'm a part of the biostatistics department. We taught a course all in Databricks using Apache Spark, and we use the Databricks genomic runtime and as well as the Glow project, Apache Glow project, which basically we taught the students how to build these large-scale genomics pipelines to be able to analyze their CRAM, their VCF types of SNP data sets. And when you think about the large amount of data, a lot of the students had to previously utilize the HPC environments, right? Where the cost to be able to build one single node on the HPC, to add on a single node for HPC for a single class could be close to anywhere from $50,000 to $100,000 to start to add nodes to the cluster to support classroom environments. And with Databricks, we were able to support this class on a minimal amount of resources. We had just $2,000 for the actual AWS credits, as well as the low cost associated with the DBUs that we were actually using for the computational aspects of the course. So not only does it cut costs, but you think about the large amount of data that you would have to store in the HPC environments. We're able to do that in Databricks. And not only were we able to store that amount of data, but each one of the students were able to access the cluster at the same time, where if you get one single node added to an HPC cluster, then there's a limited amount of usage across that node that the students can have access to at the same time at any given point in time. So we're able to have the students work together across this large amount of data, and that provided an extreme amount of value for that class, allowing the students to not only do genomics pipelines, but also apply machine learning to those genomics pipelines, giving those students not just an understanding of end-to-end genetics and genomics, but also how do you apply machine learning algorithms to those data sets and do things like deep learning across. We had a cancer data set that dealt with melanoma, and seeing if they could apply some deep learning object detection algorithms to the melanoma data sets for classification. So awesome class. It was the first iteration. We're already having questions about hey, Dr. Harvey, can you do a second part of this class? So and it really drills down to the fact that we're able to use Databricks, and we're able to have the students collaborate, and they were able to all work on these large data sets together in the same environment. And then we're currently, I also teach a data science foundations and practicum course at George Washington University. So this is a project-based course, and I'll talk about some of the structure of how we're organizing the clusters for that course. But the idea here is, it's project-based, and we're having leaders from across industry, the federal government, and academia come in and talk to the students about what it takes to be a unicorn, right? A data scientist that not only has the mathematics, the subject matter expertise, and the programming skills, but also has and understanding of, how to deploy models and how to integrate those models into the end user analyst workflows and things like that. So Databricks has been a huge proponent of that course, specifically for the project-based learning, where we have close to 20 students that all need to work in an environment. We need to spin up clusters really fast, really easy, to allow them to be able to access the data, the large scale distributed data that they'll need to be able to run their analyses. And really the focus here is not just, hey, let's have the data scientists use a Jupyter notebook and do a single, local analysis, right? We're really focused on making sure that we mimic the behavior of data that the data scientists and the students will actually see in a real organization. So that's why we're allowing our students to get hands-on data that's, large data sets. The last data set we brought in was like 64 gigabytes. We set up a GPU cluster that had like 640 gigabytes of memory on it to enable all the students to be able to bring that data within memory, so they could crank across a deep learning algorithm, so that they could see how the power of being able to run an analysis at scale helps them with their findings and their classifications. And then there are two other courses. We're planning one for the spring of 22, and this one is going to be at Georgetown. And it's going to be a data visualization and integration course. So specifically, how do you not only create an analysis and then create a data product, but how do you create a visualization from that data product? And then how do you teach the students not only to just deliver or hand deliver a product or visualization, but start to integrate that, right? We're seeing more and more of the educational curriculum geared around how do you utilize the results that are coming from these machine learning models. And then the final course that I'll be teaching over at Bowie State is really a data science bias assurance and integration course, specifically in healthcare, right? So, when you think about doctors that have to make very critical life decisions for their patients, as they are getting, MRI scans and other different types of artifacts that are associated with their patients, understanding how machine learning can introduce biases either through the data or through the model, understanding how there could be, things like adversarial perturbations that can happen against the different data sets. We want to make sure that our students understand, and from a security perspective, are aware of the different types of attacks that can happen. But from a, kind of red teaming, blue teaming perspective, or being able to create an assessment of these different types of data and of the different types of models that are being used to ensure the integrity, to ensure the security of those models, and to be able to identify when those models or data sets have had adversarial activity within them, is really what we're pointing to and trying to teach in that course. But for each one of those courses, the visualization as well as the data science bias and integration course, we're all pushing, and what we're seeing the students get extreme amount of value from utilizing Databricks, specifically for the Bowie State class, and hopefully for the future as we gear up for this George Washington class in spring 22. We're going to be pushing Databricks as well because of the collaboration, the ease of use, being able to bring in that data all at scale, have the students work together at once within the same clustered environment. You can't beat it. And thanks to the University Alliance for providing the resources to allow the students at like a Bowie State University that traditionally don't have the amount of resources like Johns Hopkins University. The University Alliance program provided resources to allow those students to be able to have, at their fingertips an environment so they could do their data science work. So thanks very much, Rob. All right, so a little bit about the academic development environments. So what we're seeing is each student starts off with a community edition account, and then each student works within an account within either Azure or AWS as well, right? So we've switched between Azure and AWS per class. It's good to get the students to have and understand how to use Databricks within both cloud service providers. And then we assign students to groups. And then we have 4 different types of clusters that we provide now. And there's actually an option within Databricks that we're currently going to be using next semester that allows you to select which type of workspace you actually want, we're starting to already see the value there, where we may not have to split up to have these different types of clusters in the future. But right now, what we do is we have a data engineering, data analytics, data science, and machine learning, as well as a GPU cluster. And depending on the analysis, we're allowing the students to run these different types of algorithms and methodologies across these different clusters per project. And then the last thing, we make sure that the students not only understand how to use Databricks, but how to get the data inside of S3 or ADLS to ensure that they can bring in, the 64 gigabyte data sets from Kaggle and then start off their analysis. So not only just the data science piece, but also the data engineering and ensuring that they have the ETL skill set to be able to bring the data in as well. Okay. All right. So talking a little bit about, where we've seen a little bit of focus as we've been teaching in regards to where we want to ensure the students have a good skill set that goes a little bit beyond just creating the models, packaging the models, and deploying the models, right? So what we've seen over time in my first 5 years of actually teaching data science is that there's been a lot of onus on, how do we develop and experiment and then package and deploy. And, there's tools out there like MLflow that does a great job, pristine job when it comes to development, experimentation, all the way to package and deploying. But once we get to the point where, the organizations that I worked with, that I came from, like a national security agency that has 30,000 analysts, right? So the question becomes, after we build this world-class model, how do we then get the results into the hands of the end user analysts so that they can use the results within their workflow for decision making? And then that's when you get into this area here where you're trying to do a couple of different things, including, I want to scale out the model across the organizational application infrastructure. And then I want to make sure that it's tuned for the application. I want to do some things like, what we call application instrumentation, where you're adding a button, you're tracking implicit and explicit behavior based upon, which users are pushing which buttons, which users are hovering over which areas of the page. So there's a lot of instrumentation that has to go on in accordance with that application as well, right? And then, the other things like the in-application CI/CD and the workflows that allow you to, take the model, and as you start to do some of the monitoring within the tool itself or within the application itself based upon the instrumentation that happened, and you start to see accuracy decrease, how do you then update the model where you have things like, the automated CI/CD pipeline where you can integrate the actual model that has been retrained directly back within that application, okay? Now, the initial phase of deployment and experimentation can take, a couple of weeks with a couple of data scientists. But what we've started to see is that when it gets to the point where you want to take that model that's been developed and you want to instrument the application so that model can be at the fingertips of an analyst or a business user, that's where you start to have, these large teams of developers, 4 to 6 plus, and it starts to include the back end, the front end, the data scientists, the machine learning DevOps. And there's a huge amount of resources and effort that has to go in to be able to get the results inside the application to where there's a button in an application that allows you to utilize those machine learning results, okay? So with that being said, the building and the experimentation, there's a lot of awesome technologies around, how do you build and deploy? MLflow is one of those. But the next step is integration. So how do we then start to take the results and integrate them in a way to where we can instrument the application very seamlessly, where we don't have to wait months to be able to get the results. We can do that within minutes or seconds. And what we're seeing is that, there's an a set of inefficiencies associated with, the inability to be able to integrate very seamlessly. And organizations are estimating that, there's $30.2 billion annually that are being lost due to these inefficiencies in integration. And, at the NSA, for an example, at an average, it was about, 4+ developers, and the cost to be able to integrate that single model, that world-class model that was developed into the application would cost about $250,000 or $480,000. And that time frame to get that model in the application to where it was seamlessly integrated, you had the instrumentation where you could track the implicit and explicit behavior. You could feed that back to the data scientists so that they could update that model and then have a pipeline for redeployment. That would take about 2 to 4 months on the lower end, and 4+ months for most organizations that I've seen. All right. And so the problem is just really that, development and deployment of the models is just a first step, but you need to have a way to have the data collected, prepared, trained, served, all the way through to repeatedly being able to do that with minimal user intervention, right? And that's the integration process, but the integration process with minimum user intervention in a way that it can be duplicated across multiple applications very seamlessly. All right. And then there's this component, right? So a lot of organizations, you do, experimentation, and what happens is that even after you find the world-class model and you tune the best hyperparameters, the organization, and I've seen this in a couple of organizations, specifically the National Security Agency, there's still this trust factor. Even when you've kind of tested, you can prove that you have a valid model and is ready to be deployed. Even when you've done your A/B testing off 20% of the data, there's still questions when the analysts have in regards to being able to trust the results of that model in a live or production environment. Okay. And so one of the ways, and I put a lot of research into this during a couple of grants that I had at George Washington University as a research professor, but it's really, we talk about, augmented analytics. We talk about human augmentation. We talk about augmented reality. But the idea is, how do you then start to cut down the time that's associated with that integration in a way that you can overlay the technology on top of the field of view for the analyst, right? So not just taking the results and then providing a data product or visualization, but intentionally injecting the results of the machine learning inside of the field of view so the analyst doesn't have to learn a new tool, and the analyst can be augmented, right, in a way where they're in their field of view, they're using one of 4 or 5 tools that they use on a day-to-day basis. And now you can say, hey, here's the results. We're going to point you to the most significant insights, and we're going to provide you the context as to why this machine learning recommendation or this machine learning classification or this machine learning result is important. So it's just an idea of, superimposing or injecting the intelligence or the machine learning results inside the field of view of the end user. All right. So the idea is of currently is that, analysts and data scientists are siloed, and there's not a lot of trust after the models have been deployed. So what we've been working on is really a way to create these models that you can take, you can drag and drop them into your browser, and then you can automatically have live predictions on the web page or within the field of view for that particular analyst. And then not only can you have the results, but you also can provide the user feedback that can help the retraining pipeline, okay? All right, so how's this being done? So you can utilize any of your legacy, training or optimization, legacy training machine learning frameworks. And what we're doing is a level of optimization so they can run very well inside of an application. And then you're able to utilize a conversion framework as well as a model integration API that we developed. So with 5 different, around 5 or 6 different lines of code, you're able to take a model, a legacy model that has been trained in one of the more popular machine learning frameworks, and create this representation of that model that can be easily integrated into an end user application, and the results can be overlaid into the field of view. All right. And one of the areas that I wanted to talk about a little bit was really the tight integration with ML Flow. So we talked about providing that back propagation of the results back to the data scientist, so the data scientist can retrain the model. So basically, you can take your historical model, and in this middle section, you see model training here. Take your historical model. All you do is call in the AI squared library. You say, hey, I want to add in some metadata that's associated with this particular model, so that I can create a model that can be integrated very seamlessly into an application. So some of the things you do is you call the model, you call the library, you say, hey, I want to explain the library in a configuration file, but I also want to log the metrics. So any metrics that you're interested in logging using ML Flow, you basically log those metrics, and those are the metrics that the data scientists will receive in real time that's associated with the live back propagation from the actual analyst within their field of view. So as we provide live predictions to the analyst provides feedback, and we log that feedback directly back to the data scientists within their field of view in a notebook or an ML Flow. And I'll show you guys a little bit about how that's being done. But the idea is that you come up with a couple of lines of code. Now we're allowing you to take your model, integrate it into the end user application, no matter what legacy framework you're using, and now you can overlay the results inside of a end user application. All right. So real quick, I'll show you guys a little bit about how that works. Right. So right now we have an SDK that allows you to create a simple application, and right now what we've done is we baked in our SDK in the form of an extension. So you can drag and drop your model inside of the extension after you've integrated with our model integration API. And what we do is we convert it, and we allow the results to be overlaid directly within the field of view of the end user. So what happens is that after you drag and drop your model over, you can start to see some of the object detections or image classifications being rendered directly on top of the field of view after you drag and drop your model. So what we're doing is we're augmenting the cognitive decision-making process of the analyst directly within their field of view by using the model that the data scientist has built to be able to point them to the most significant insights. Okay. And what you guys see here are a couple of different models that we've been able to integrate, where we've just done image classification. Another example is, running an object detection. And this is for any application at this point that has the ability for us to process the images from the DOM, right? And automatically what's happening is that we're overlaying and rendering the objects directly within the field of view for that analyst using that model that was just integrated within seconds. And the last example is just an image segmentation model that we dragged and dropped into the browser. And within the field of view of that analyst, there's this image segmentation that's happening directly in the field of view of that end user. And an example of taking that model that we built, that we added in our model integration API, it's very simple. You basically name the model, you identify the level of performance, you talk about what type of model you're trying to bring in, and then you bring that model in that's been integrated with our API, that legacy model, and you bring it in, and now you have a model that can be directly integrated on top of the field of view for that end user or that analyst. And we've seen a lot of success of this at the National Security Agency. There are multiple users that are using the technology at the National Security Agency. And we're hoping to be able to get this in the hands of some organizations and industry. And the last thing I'll talk about here is really the back propagation. So not only are we doing that for the analyst, the last piece that I want to show is really, how the results are being back propagated. So let's see. Yes. So as you guys can see, the results of each one of the classification accuracies, we can back propagate those. Now, what we're doing is based upon the metrics that we identify within the actual model, we're using MLflow to log those either positive assessments, negative assessments. We're coming up with a ratio as well as the overall accuracy. And that accuracy is tied to a particular model. So over time, what the data scientists can see is the accuracy of the model that was actually deployed into the end user application. So not only are we giving the analyst a streamlined access to the results of the model, we're also back propagating the results right back to the data scientists in their notebook within MLflow in Databricks, so that they can see in real time the accuracy and performance of that model in a live production environment. And this piece would take months. And what we've been able to do is create a pipeline to do that within minutes or seconds. Okay. All right. So I will stop there. That's my last slide. And then we'll turn it over for questions.
I'm sorry, Ben. I just have to say, this part of my head just exploded when all those pieces fit together, and I realized, my past life as a business analyst, the time it took for those dots to get connected and to see it, the possibility of it happening in real time, but also putting a human being between the final decision making of an algorithm versus, what could happen to personnel in the field. It's just love it. So that's my opinion. I've got a couple of questions from the YouTube channel and the LinkedIn side, but I've got one Q&A. Let's see. That's somebody asked if you have links or could share your class syllabus from either Bowie State or George Washington or both, and you can just put those, I guess, directly in the chat window, and then I can share that on LinkedIn and YouTube as well.
Yes, definitely. I will do it. And I'll also send a direct copy to you, Rob, as well, so that you can have it. Yep.
Great. So let's give Dr. Harvey a minute or so to do that, and then I'll go on to the next question. And I think this one is coming from YouTube. And when you're ready, Ben, just nod your head and I'll ask you the YouTube question. I think, Ben, you're on mute. Let's see.
Yes, posting now.
Okay, great.
Right. So, and I'll post my email address as well, so you can reach out and get the any other materials that you might need as well.
Great. All right, so I'll put this in the YouTube and LinkedIn. Oops.
I'll also, after we finish, I'll put it into the YouTube recording copy tip so folks can access it.
Yeah, and Karen, if you could do the YouTube, I don't think I'm logged in, or something to where I can't put it in the chat. So
yeah, sure, I'll do that right now.
Okay. And then let's see. So there's the email address. So LinkedIn's taken care of for the syllabus and the email address. So Dr. Harvey, can you please speak to what part of the demo was AI squared workflow versus ML flow?
Yes. So great question. So there are two pieces of our integration API. We are using ML Flow's integration API specifically to be able to back propagate the results. Once we push the model into the workflow of the end user, we're back propagating the results into the data science notebook, right? So the ML Flow API allows us to do the back propagation into the data science notebook or into the ML Flow server. But we also have our own integration API components that help us explain the model so that our SDK can do the integration, right? So there are two components of our integration, explaining the model inside of the actual code. We're logging, and that's directly logging through ML Flow. And that allows us to back propagate the results from the actual field of view into the Databricks notebook. And then the API piece that is saying, hey, here's the layers of the model, right? Here's the custom layer number one, custom layer number two, the input, the output. And here's how I want the integration to happen. I want the integration to happen in regards to images versus natural language processing. And natural language processing, you can identify and say, hey, I want a highlight or underline. So that's explaining how you want the integration to happen inside of the model. And ML Flow is specifically for the back propagation.
Okay, great. I think we can answer one more question, and this would come from the YouTube channel, Rashid. Do we still need manual input to validate the ML model predictions? And are there any developments on validating the model in automation?
Yes, great question. So that's a great point. And so what we've seen is it really depends on the type of organization that you are providing the solution for. So we've done a couple of POCs with healthcare organizations as well as the National Security Agency. And for those organizations, they always want that human in the loop to be able to provide that validation or that vetting because of the catastrophic downstream effects that a wrong decision could actually have. So for those organizations, we've seen 100% of the time they want eyes on the actual results so that they can understand how that model is performing. Now we are looking at assisting the machine learning in identifying identifying which types of images would have the highest level of accuracy to kind of support the decision on which ones we should run inference over first. But when it comes to assuring that the actual results are vetted and validated, a lot of our organizations, they relish the fact that they can provide that human in the loop to actually give us an indication of how the model is performing, right? So there is an aspect of, we don't just rely totally on the human, but we also rely on the algorithm to be able to determine the accuracy. But the human in the loop is really what we've seen a lot of organizations relish.
So we're at 1 minute to the hour. Karen, I'll turn it over to you. Ben, thank you so much. I always love meetings where my brain struggles to get a little bigger from the concept. So thank you, sir. And Karen, I'll be quiet now.
Thank you, Rob.
Yeah, thank you so much, Ben, and great to have you, Rob. Always awesome to hear more about the program and have some of your professors speak. So with that, thank you everyone for joining. I dropped the YouTube link in all of the chat spaces, so you can revisit the session at a later time. And I'll also post the link to uh, Ben's syllabus and his contact information in the YouTube description as well. So with that, I hope everyone have a great rest of your day and take care. Thanks so much. Bye.
Thank you, everyone. Bye-bye.